ஓகே, ஹாய் ஃப்ரெண்ட்ஸ். அதாவது ப்ரீவியஸ் கிளாஸில் வந்து மேட்ரிக்ஸ் மல்டிப்ளிகேஷன் வந்து எப்படி பண்ணுறது அப்படின்னு பார்த்தோம். அதாவது டூ மேட்ரிக்ஸஸை வந்து நம்ம வந்து ஜியாமெட்ரிக் வேல வந்து எப்படி வந்து மல்டிப்ளை பண்ணணும். அதாவது மேட்ரிக்ஸ் மல்டிப்ளிகேஷன் வந்து எதை குறிக்குது அப்படின்னு பார்த்தோம்னா, ரெண்டு டிரான்ஸ்ஃபர்மேஷன், அதாவது லீனியர் டிரான்ஸ்ஃபர்மேஷன் என்னென்னு பார்த்தோம். அதாவது ஒரு ஸ்பேஸை வந்து இன்னொரு டைப்பாக வந்து இந்த ஸ்பேஸ் வந்து டிஃபார்ம் ஆகிறது தான் வந்து லீனியர் டிரான்ஸ்ஃபர்மேஷன். லீனியர் டிரான்ஸ்ஃபர்மேஷனோட கண்டிஷன்ஸ் பார்த்தோம். இப்போது ஒன் டிரான்ஸ்ஃபர்மேஷன் அப்படின்னு பார்த்தோம்னா தட் டினோட்ஸ் ஒன் மேட்ரிக்ஸ். ஒரு ஸ்பேஸ் வந்து இன்னொரு டைப்பாக வந்து கன்வெர்ட் ஆகிருக்கு அப்படின்னா that we can define as a matrix. Then if you multiply with that matrix with one vector, for example, now if you consider actually we have taken one vector minus 2 and 3. Okay, so we have taken this vector minus 2 and 3 before. Now example is okay, so this is our initial position of this v vector. So this v vector denotes minus 2 and 3. So I have taken minus 2 and 3. Now if you do 90-degree rotation in clockwise direction, and then what will be the rotational component? That rotational where the I cap and j cap will go. So before this is the I cap position and this is the j cap position, unit vectors. So these unit vectors, where it will go after the transformation, after the 90-degree rotation, you have to determine where I and j cap will go. So if you find I cap and j cap, these unit vectors, then you can determine this v vector. What is the position of this v vector? You can find. So what is the position of I cap? 0, minus 1 and 1, 0. This is the position of I cap. So if you multiply with this transformation, this denotes the matrix 2 into 2 matrix, 2 by 2 matrix, because it has 2 columns and 2 rows. So this denotes 2 into 2 by 2 matrix. Now because we are taking the 2D space, okay, because here we are dealing with only 2 dimensions. So in the 2 dimensions you have I cap and j cap. So for the I cap it has 2 coordinates, and for j cap it has one more 2 coordinates also. So totally 4 coordinates. So this denotes where I cap land, and this denotes where j cap land. Okay, after the transformation, where this column represents where I cap, this I cap, representation of this I cap transformation, then transformation of j cap. So this overall, this is 2 by 2 matrix. Now see, if you multiply with this matrix transformation with this vector minus 2, 3. So already I have defined. So this gives minus 2 times this column plus 3 times this column. You will get what? 3 into 2, 3, 2. Now if you multiply this, you will get 3, 2. So this is the effect. So, and also we have seen about what will be the shearing effect. Shearing effect after the transformation is done. Shearing transformation is done. So our homework was what is our homework? So we have to determine, actually we are getting this combined effect in 2 ways. One way is, first I am going to shear this plane and then I am going to rotate. Okay, so now this is the initial position. Now I am going to shear the plane. Okay, so now what will be like this? So this, after the shearing, that transformation is done, shearing transformation is done. Now this v vector will go in this place. Okay, now this v vector moves here after the shearing transformation. Now if you consider, this is the second line. Okay, so now the position of this v vector, the initial position is this one. Now where, if you see, Now this line goes here. Okay. So now before the transformation, this line should be here. So after the shearing plane, now this plane is goes. So this tip will move here. Okay. So now what will be the position of V vector? Now you have to find this V vector, where it will go. If you find, you have to find. So to find this V vector, you should know I cap, where I cap will go and where j cap will go. If you find this unit vectors, if you focus only this unit vector, you can find V vector. Okay. So first I am doing the shearing transformation, and I am doing this plane into 90-degree rotation, 90-degree clockwise rotation. Okay. What is 90 degree? This will give the 90 degree. Suppose this is a 90 degree. So suppose this will be the plane, first initial position. Now if you do 90 degree, this axis will go in this way, okay, in clockwise direction. So this is the first initial position. If it is the initial position, after the 90 degree transformation, where it will go? Now it will transform in this way. So this is a 90 degree rotation. So if I am doing this, and now it will go like this. It will rotate 90 degree, and this transformation will go in this way. Okay. So now after the combined degree, after the shearing, we are doing the 90 degree rotation. After the 90 degree rotation, this diagram, this vector will go like this. So this will be the final I cap and landing I cap, and this is the final j cap. Now if you find I cap and j cap, and if you multiply with this v cap, you will get any vector. So now what I am doing is, first I am going to find what is the combined effect by doing first shear plus 90 degree rotation. Okay, first I am going to calculate what will be the combined effect. What will be the combined effect? First shearing and 90 degree rotation. So what will be the shearing effect? What will be the shearing transformation done? After the shearing transformation done, what will be the position of I cap and j cap? Okay, now what will be the position of I cap and j cap? This is I cap denotes 1, 0. This is j cap denotes 1, 1. So this will be the shearing transformation. So this denotes matrix. This column represents where I cap lands, that is where I cap will go. Then this column represents where j cap lands. Okay, now this is a matrix transformation. Okay, linear transformation, shearing transformation. Now I am going to multiply this transformation with the 90 degree rotation. So 90 degree rotation components, if you see, because this will give 90 degree rotation components. So after the 90 degree rotation, so for example, consider this plane. Now first thing is I cap is here, j cap is here. After 90 degree rotation, where it will go? This I cap and j cap. So after the 90 degree rotation, what will be the linear transformation components? The I cap lands on 0, 0, -1, and j cap lands 1, 0. Okay, 0, -1, 1, 0. Now I am going to multiply these two matrices. So already we have seen in practical way in earlier classes how to multiply these matrices. Now if you find, now I am going to, so actually practically how to multiply these are. Now I am going to multiply these matrices by using a shortcut method. Okay, so first you have to take this row and this column. So when doing the matrix multiplication, you have to multiply with the corresponding entries. Okay, so you have to multiply this 0 into this one. Okay, then this plus this 1 into this one. Okay, so 1 into 0, 0. So after that, for to to find this column, you have to find minus 1 into minus 1. So minus 1 into 1 plus 0 into 0, 0. Okay, so now you got one column. So in the previous classes, we have developed in a practical way, in geometric representation, how the multiplication is done in a geometric way. Please refer this previous videos. Okay, now we are doing in a shortcut way. Now, and after this, you have to find this column. Okay, so 0 into 1, 0 and 1 into 1 plus 1, and then minus 1 into 1, minus 1, and 0 into 1 plus 0. So what you get from these equations? 1, 1, minus 1, minus 1. Sorry, this is 0. 0. This will be the minus 1 into 1. Okay. So minus 1, 1, minus 1. Okay. This will be the combined effect of first shearing and 90-degree rotation. This is the combined effect. This is the linear transformation. So dual effect. First we are doing shearing and then 90-degree rotation. So if you multiply both, you will get the combined effect. This will give the combined effect. So if you multiply with this first initial position vector minus 2 and 3, minus 2, 3, you will get where it will land. Okay, now you can find where it will go. So 0, so how to multiply? 0 times minus 2 plus 1 times 3. So you will get 3, and minus 1 times minus 2 plus 2, minus 3, so minus 1. So 3 comma minus 1 will be the new position of this V vector, position of V vector. So 3 comma minus 1 you got in a practical geometric representation. Okay, now here you can give any vector. In general notion, you can give any vector. Okay, you can give any vector, xy vector. If you multiply with this vector, you will get the final vector after the transformation. Okay, now I am erasing it. Okay, this will be the, so only I am considering the unit vectors only. So this will be the combined effect of first shearing and then rotation. Now what I am going to do is, first I am going to rotate it into 90 degree. Okay, first I am going to rotate in 90 degree. Okay, I got, this is the first position. Now I am going to rotate in 90 degree and then I am going to shear. Okay, then what will be the net result? Actually I have done, actually you have completed your homework, right? So first you have to do this 90 degree rotation, after that you have to shearing, and then where this V vector will go after the shearing. Okay, so first you are done what? So it is the reverse way. Okay, so you have to multiply in the reverse direction, you will get the, okay, you will get the combined effect. First 90 degree rotation and then shearing. So first in the reverse way you have to do 1, 0, 1 comma 1 into 0 comma 1 minus 1 comma 0. Okay, so now before that I am taking this vector as A vector and this vector as B vector. So this is A into B. Okay, this is A vector, this is B vector, so this denotes A into B. So here this is B vector, this is A vector. Okay, now I am doing the matrix multiplication. Now 1 into 0, 0 plus 1 into 1, 1 into minus 1, minus 1. Okay, then 1 into 1 into 1, 1, 1 into 0 plus 0, then 0 into 0, 0, 1 into minus 1, minus 1, 0 into 1, 0, 1 into 0 plus 0. So here you will get what? Minus 1, 1, minus 1, 0. So actually please once again check it. 1 comma 0 1 1 and 0 1 minus 1 0. So 1 into 0 0 plus 1 into minus 1 minus 1. 1 into 1 plus 1 into 0. and 0 into 0, 0 into 0, and plus 1 into minus 1, minus 1. 0 into 1, 0, 1 into 0, 0. So you will get minus 1, 1, minus 1, 0. Now this is the B into A. Okay. Now so because we are doing in the reverse direction. First in this case, first shearing, and then after that we are doing 90-degree rotation. In this case, first rotation and then shearing. Then you will get this resultant. This is the combined effect. Now you compare with these two results. Now whether it will equal or not, it is not equal. Okay. So if you do this two transformation in reverse direction, it will not equal. So what you conclude is that whether A into B equal to or not equal to B into A. This will be your conclusion. Okay. So this what is a property, you know. So this is a commutable property. Okay. So we could not change, we could not reverse a reverse multiplication. We could not do reverse multiplication because it will not be equal in the matrix multiplication. Because suppose for the whole numbers, what is the commutable property? So suppose we say for whole numbers, what is whole number? Okay, what is whole number? So before knowing the whole number, you have to know what is natural number. So what is natural number? The natural numbers are countable numbers. How to suppose you are in the situation to count any numbers. For example, in front of you there are many persons in a meeting. Okay, in a meeting there are some persons in the meeting. Now you have to count one by one how many the persons are there in the meeting. Okay, so how to count? Now you have to count from the number 1, 2, 3, 4. You are not counting from 0. You are counting from 1, 2, 3, 4, 5. It goes on unlimited. So this 1, 2, 3, it goes limited, unlimited. So these numbers are natural numbers. Okay, these numbers are natural numbers. Now, if you add with these natural numbers before 0, okay, if you add 0 with these natural numbers, you will get whole numbers. Okay, what you conclude is 0 is a whole number, not natural number. 1 will be the whole number or natural number. So 0 will be not a natural number, this is a whole number. So one property of the whole number is commutable property. Commutable property. What is this? A into B is equal to B into A. Okay, this is the commutable property for whole numbers. This denotes if you multiply two numbers, for example 3 into 2 will be equal to 2 into 3. Okay, because if you do reverse multiplication, it will be equal. This is the commutable property of whole numbers. So, but if you take in the matrices, this A into B will not be equal to B for matrices. For matrices, A into B will not be equal to B. So, this is the case. So, I have done this homework. I think I have done this homework. Okay. So, first shearing and rotation, and then second case rotation and shearing. So, these two effects will not be equal. This is a conclusion in our problem. Okay. So, matrices it's not satisfying the commutable property. Okay. So, AB should not be equal with B into B. Okay. You understood? Okay. This is the geometric representation of how matrices is denoted in the 2D dimension. So one point you have to note it. This we are representing these matrices in 2D dimension. That is 2 dimension in the space. Okay. So if you if you consider that dimension is a direction, then one more dimension you have to add. So in this space we are only considering two dimension. So So if you add the dimension, it is more difficult to represent this vector in this space. So it's more difficult to understand. That's why I'm only considering 2 dimensions in our classes. So for 3 dimensions, you have to imagine yourself how these three vectors will be represented in the 3 dimensions. Okay, then how the matrices will go like this, how the matrices will be multiplied, and these things you have to imagine in our mind. Okay, so this is in the only we are explaining in the 2 dimension. Okay, and now so we have completed our classes now. So please note it. So in 3 dimensions, what will be given? So in 3 dimensions, we will have I cap, j cap, and k cap. Okay, because there will be 3 unit vectors in 3 dimensional way. So if you will have 3 coordinates 1 0 0 0 0 0 1 0 for j cap and 0 0 1 for I cap. So this will be the unit vector. So before the transformation is going, is the initial position of I cap, j cap, k cap will be 1 0 0 0 1 0 0 0 1 0. So this denotes this unit matrix. So this is in 3 dimension. Okay. So actually we are going to complete this class. So if any doubt, please mail us or call. Okay. Anyway, thank you friends. Okay. Bye.